Welcome back to AP Statistics. This is Dr. Kling, not affiliated with the College Board. We're on to lesson 19, which is working with the normal distribution. I call it the case of the missing sigma. So suppose you get back a score on a standardized test where you know that the mean is equal to 50 and you get 68, and you'd like to know what percentile it is. And you're told that a score of 60 is in the 70th percentile. That is 70% score 60 or less. And so, and you would like to know what percentile you have. Well, you want to do some kind of norm CDF. And you know that you're going to get get your z-score is equal to 68 minus 50 over sigma. But whoops, they didn't tell us what sigma was. But it turns out, because they gave us this information, that a score of 60 is in the 70th percentile, we can figure out what sigma was. So here's going to be our strategy for that. If we draw a normal curve, and we know that the mean was 50, and they told us that a 60 was in the 70th percentile. We can go from here to calculating a z. We'll use inv norm for that. That'll give us a z. And then we can set z is equal to 60 minus 50, that's x minus mu, over sigma. Okay, and once we know what z is, we can solve for sigma. So that's our strategy. So the first thing we need to do is take the inv norm of 0.7 to get us to where the 70th percentile will be. And that's 0.524. Okay, now we can put 0.524 into that equation. And so, just using algebra, sigma is going to equal 60 minus 50 over 0.524, and that turns out to be about 19. So now we no longer have a missing sigma, and we can go back and solve our problem. So z is equal to 18 over 19 roughly, and 68 minus 50 is 18, and the sigma that we just found is 19. So this will be about 0.9 something. What is it, 0.94, something like that? Yeah, 0.944. And now we can do a norm CDF from negative 10 to 0.944, and I think we get something like 0.823, something like that. So that gives us our percentile. We're in about the 82nd percentile. So that's an example of the case of the missing sigma, and that's it for this talk.